Couple more problems like we were working on in the last video. Okay, so let's see. If x equals 7, so that's my hypothesis. Okay, so my hypothesis, which is my P, x equals 7. Okay, then x is an odd number would be my conclusion. So my conclusion, okay, which remember you usually use a Q, okay, x is an odd number. Okay, so it wants us to do the converse. Okay, then the inverse, then the contrapositive. Okay, so again, you go back here and say, okay, the converse, we don't negate it, we just switch to P and Q. So it would be Q implies P, or if Q, then P. Okay, your inverse, okay, means we don't switch them, we just negate them. Okay, so non-P implies non-Q, or if non-P, then non-Q. And then your contrapositive, we switch them and negate them. Okay, so non-Q implies non-P, or if non-Q, then non-P. Okay, so let's see. All right, so we're switching these guys, so our converse would be if x is an odd number, then x is 7. Which would make no sense because I could find a whole bunch of odd numbers that don't equal 7. Okay, so that would be false. Okay, so inverse. So we don't switch them, we just negate them. So I need to negate x equals 7. So if x doesn't equal 7, then, well, I can negate that two ways. I could say x is not an odd number, or I could say x is an even number. X is an even number. Okay, and that would make sense either, because I say, okay, if x is not 7, then x has to be even. No, if x is not 7, maybe it's 11. 11's not even. Okay, and then we say non-Q non-Q implies non-P. So we could say, okay, we could say x is not an odd number, or we could say x is an even number. If x is an even number, then I have to negate that. X does not equal 7. Well, that would be true, because if x is any even number, it's certainly not going to be equal to -7. Okay, so that's good. Okay, let's see. Okay, if I do not stop at the stop sign. Okay, so let's see. My hypothesis, my P, I do not stop at the stop sign. Okay, then my conclusion, and remember that's my Q, then I will be given a ticket. Okay. Okay, so let's see, we've got to do converse. We've got to do inverse. And then we've got to do contrapositive. Okay. So again, we just keep coming back to this guy. Okay, so converse, we don't negate anything, we just switch it. Okay, so if Q, then P, or Q implies P. Okay, inverse, we don't switch them, we just negate them. Okay, so if non-P, then non-Q, or non-P implies non-Q. And then your contrapositive, you both switch them and negate them. Okay, so non-Q implies non-P, or if non-Q, then non-P. Okay, so let's see. Okay, so if Q, then P. So if I get a ticket, then I didn't stop at the stop sign. Okay, so if I get a ticket, then I didn't stop at the stop sign. Now, that would be false. Let's suppose if I got a ticket, maybe it was because I was speeding, not because I went through a stop sign, so that would be false, okay? All right, so let's see, inverse, non-P implies non-Q. So if, I have to negate this, I do stop at the stop sign. If I do stop at the stop sign, then non-Q, I will not get a ticket, or I won't get a ticket. Okay, so if I do stop the stop sign, then I won't get a ticket. Well, that's false too. Once again, let's suppose you do stop at the stop sign, but let's suppose you were speeding, okay, before you stopped, okay, and the cop pulls you over and gives you a ticket. Okay, contrapositive. So if non-Q, then non-P. So let's see, if I won't be given a ticket, or if I don't get a ticket, so if I don't get a ticket, then I have to negate this. I did stop the stop sign. I'd say that's false as well. So let's suppose I don't get a ticket. Does that mean I stopped at a stop sign? No. I could have gone right to the stop sign, but there was no cop around to see it happen, so he didn't give me a ticket. Okay, so all three of those are false. Okay? All right, now we want to start working on biconditional statements. Okay, so if you have a statement and its converse, okay, and obviously we want the biconditional statement to be true. So if a statement and its converse are both true, we can combine them into one statement, and we call this a biconditional statement. Okay, so a statement and its converse, okay, have to be true, okay, to make a true biconditional statement. So to give you an example what I mean. Okay, so let's suppose we start here. If an angle measures 90 degrees, then it's a right angle. So if an angle measures 90 degrees, so this would be my P, okay, then it's a right angle. That would be my Q. Now the converse, okay, remember, means that we just switch. We don't negate, so we just switch it. And I say if it's a right angle, so notice the Q comes first, then the angle measures 90 degrees, and notice the P comes second. So if P, then Q, if Q, then P. Now both of these are true statements. So if an angle measures 90 degrees, it's definitely a right angle. That's true. And if it's a right angle, then it has to measure 90 degrees. That's true as well. So we can combine these two statements into the biconditional statement using this. Okay, now when you do that, it doesn't make any difference whether P comes first or Q comes first, okay, because we can read it forward and backwards. So if an angle measures 90 degrees, if and only if it's a right angle. Or you could read it backwards and you say it's a right angle if and only if the angle measures 90 degrees. Okay, so it doesn't make any difference which order the P and Q come. You could put the P first and the Q second, or you could put the Q first and the P second. It makes no difference because we're using this if and only if, which means we can read it going forward and then we can read it going backwards, okay? Now, there's some notation and terminology, okay? We have this if and only if, okay? You saw that already, okay? Sometimes we use arrow notation like this. It's still read P if and only if Q. And then sometimes we abbreviate, okay, the if and only if into this IFF, okay, which I used to see all the time in my college classes, okay? The professors would use that, okay? So I could rewrite this two other ways, okay? I could say an angle measures 90 degrees if and only if, so I would have to have the double arrowed, it's a right angle. And we still read it, an angle measures 90 degrees if and only if it's a right angle. Okay, the other way I could do the same thing, an angle measures 90 degrees if and only if, and I use that IFF, it's a right angle. Okay, an angle measures 90 degrees if and only if it's a right angle. I use this IFF as much as possible, okay, but it doesn't make any difference, okay? So we have three different ways to represent a biconditional. Okay, so let's see. Okay, so in any biconditional statement, P if and only if Q, okay, the two conditional statements are P implies Q and Q implies P, okay? So we have to have a statement and its converse, okay? Obviously, these two statements are converses of each other, okay? And then this biconditional right here is true only if both of these guys are true. Okay, so if both conditional statements are true, then the biconditional is true. Okay, if either or both of these are false, then the biconditional would be false.